Okay, so let's do a couple more completing the square processes. Number one, to get used to the steps, if you would, and then number two, handle fractions. So that's what's going to happen here in some instances, and we're just going to have to keep following the steps and push fractions around. So in the first one, the lead coefficient is not 1, so that's my first problem. Easy, we'll just divide everybody by 3 to get rid of it. So that gives us x squared minus 5x plus 2 is equal to 0. And so there's our first step. Next one is to make sure that the terms that represent the incomplete square are isolated. They're not. So I need to subtract 2 from both sides. So far so good. Now we start the completing the square process. So to complete this square, I need to take the negative 5 and divide it by 2. And unfortunately, we just are left with that fraction. That doesn't simplify. So to find out the area of the missing part, right, we square that, giving us 25 over 4. So to complete the square here, I need to add 25 over 4 to both sides. Okay? Now again, this side, if we've done everything right, is a nice perfect square trinomial with that number playing a role in the factorization. So we get x minus 5 halves squared. On this side, we have fractions to add. So I think common denominator is 4. So this becomes negative 8 over 4 plus 25 over 4. And I think what we're getting there is 17 over 4. So there would be our answer at this juncture. We can use the square root property finally, right? So I'll apply the square root to both sides. That introduces a plus minus. Over here, everything clears out and we're left with x minus 5 halves. And meanwhile, on the other side, we have plus or minus. We have square root of 17 on the top, and the square root of 4 is 2 on the bottom. So that would be all we can do with that. That doesn't simplify anymore. To solve for x, right, we're going to add 5 halves to both sides. And so our x is 5, right? They cancel out over here, 5 halves plus or minus the square root of 17 over 2. All right, now to set the stage up what's going to happen, there's a couple of ways we can write this. The first way is to recognize it as the two answers that it is, right? So it's minus 5 halves plus the square root of 17 over 2. Or it's 5 halves minus the square root of 17 over 2. So there's two answers there. The other way to write it is to put it all together, right? Notice that whether I'm adding or subtracting, the denominator is the same. So I can keep that denominator and then basically add or subtract my numerators. And that's going to be kind of important for us, but realize that there's the two answers there. So very, very complicated problem for lots of reasons. Number one, we're pushing fractions around. The steps are the same, right? So the same old steps that we've been learning, but we're pushing fractions around, and then even the radical didn't simplify very nicely. And so we had to kind of consider that. Unlike the last examples that I did in the last video, everything was just even though they started hard, they turned out nice. This one just continues to be tough. All right, and this is where, again, those ancient cultures were thinking, hey, we got something that works all the time, but the method kind of stinks, right? There's a lot going on. And that doesn't mean we're not going to learn it, because it turns out there's a lot of good stuff happening here, and that you'll use later. But so that's why we just make sure, even though the method kind of stinks and you're going to learn the quadratic formula just like the ancient cultures did, we got to understand these steps, because they're going to be like a huge role. So last one, let me give myself a little bit more room here. So again, the first problem is my leading coefficient is not 1. So easily done. I'll just divide everybody by 2. And this gives us x squared minus 1 half x plus 1 equals 0. All right. Here's the pieces that represent the incomplete square. So I'm going to isolate them by subtracting 1. So far, so good. Now what we have to do is take whatever b is, so it's negative 1 half, and I have to divide it by 2. Well, how about I write it like that? Of course, if I divide by 2, we multiply by reciprocal, and we get negative 1/4. So again, keep that on your radar, because that's going to help us factor later on. Right now, what I need to do is square it, because this gives us the area of the missing chunk. So to complete the square, I'm going to add 1/16 to both sides. Right, that completes the square on this side, that balances off on the other. This is a perfect square trinomial, very hard to see how it factors, which is why keeping that around is important. So that factors as x minus 1/4 squared. Over here, this is negative 16 over 16 plus 1 over 16, so that's negative 15 over 16. Okay, so lots of fraction pushing around that we had to worry about, but the steps are the same. All right, we're still making sure the lead coefficient is 1, isolating the incomplete square part, taking my b and dividing by 2, right, squaring it to get the missing chunk, adding the missing chunk, and then factoring the perfect square trinomial. So that's the same rhythm. Square root property now is in play. Okay, over here, the radical wipes clean, and we end up with x minus 1/4. And over here we end up with plus or minus. Well, upstairs we have the square root of negative 15, and downstairs the square root of 16 is 4. All right, and if we clean that up further, right, we have plus or minus, this is actually I, the square root of 15 all over 2. Right, the square root of 15 is not nice. Square root of negative we know is I. So this actually has complex roots. So to get x by itself, I'm going to add 1/4 to both sides. I don't have like terms, right? So what we end up with here is 1/4, right, plus or minus I square root of 15 all over 2. All right, and again, there's two answers there, right? There's the 1/4 plus and the 1/4 minus. All right, so that's a pretty solid answer. But to set up the stage, what I'd like to do is put this all together. And so I'm going to need a common denominator. So if I multiply this by 2 over 2, we get 1/4 plus or minus 2i square root of 15 all over 4. And that would give us 1 plus or minus 2i square root of 15 all over 4. And that is probably the more appropriate answer or heading. And then keep in mind there's two answers, right? There's one plus that, one minus that. And they're both complex. So again, we have another situation, because we have the I and that's positive, we have another system that's in resonance, okay, which again is not good vibrations. All right, so there's your completing the square. That's about as tough as it can get. And again, just like the ancient cultures were like, man, there's got to be something easier. And there actually is. And that's our next section, 11.2. So I'll see you guys then. Make sure you get this quiz done. And we're almost done, you guys. Keep it up.